Turn to page 471. The last lesson for this week is 116, and we're going to cover the fundamental counting theorem. I think I'll just go ahead and we'll work on the first example, and I'll explain to you how this works when we get to that point. The first problem says, how many different ways can the numbers 3, 5, 7, and 8 be arranged in order if no repetition is permitted? So how many numbers do we have here? There's 4 of them, right? So we're going to put 4 boxes here. And it says that no repetition is permitted. What that means is once we use one number, we can't use it again. So if I put all 4 of these into a bag and I shake them up and I have someone pull one out, how many do they have to pick from? There's 4 in there, right? Okay, so now we pick one out and we lay it over here on the table. So now how many numbers are left in the bag? There's only 3 of them, right? So we have 3 to choose from now. We pull one out and we lay it on the table. We don't put it back because it says no repetition. So now I'm shaking up the bag, and how many numbers are still left in the bag? There's only 2. So there's 2 to pick from here. And we lay that one on the table. So now how many numbers are left? There's only 1 left, correct? So we pulled them all out. The fundamental counting theorem says that once you know how many items you have to pick from each time, to find the total number of ways that you can arrange those, you simply multiply the numbers that are in the boxes. So there's 4 times 3 times 2 times 1, which would be 24. So there's only 24 ways to rearrange 3, 5, 7, and 8 in different numbers when you can't use repetition. You can't use one number twice. All right. The next one says, how many 4-letter signs? So we're only going to use 4 letters, so we're going to have 4 boxes. How many 4-letter signs can be used from the letters in the word equal if repetition is permitted? That means we could put all E's in here, or all Q's in here, or all U's. All right, so how many letters do we have to pick from? 1, 2, 3, 4. There's 5 letters, right? So we shake them all up and we pull one out. We've got 5 to pick from. But repetition is permitted, so we throw that letter back into the bag and we shake them all up and we pick another one out. How many do we have to pick from? We still have 5. We're going to pull one out, but we're going to put it back in, so how many do we have to pick from the next time? 5 again. And the same thing, you pull one out, put it back in. How many do we have to pick from? 5. So 5 to the 4th, which is, because it's 5 times 5 times 5 times 5, so there would be 625 ways to arrange the letters in the word equal if repetition is permitted. Okay, next, this will be a good lesson for you if you take a multiple choice test. It says a multiple choice quiz has 8 questions. Okay, so we have 8 questions. 2, 3, 4, 5, 6, 7, 8. There are 4 possible answers to each question. How many permutations of the answers are possible? You notice it doesn't say anything about repetition. Okay, but we have 4 possible answers. If you're not allowed to use repetition, what's going to happen after you answer the 4th question? There's not going to be any answers, are there? So is repetition permitted? Yes, it is permitted. They don't tell us that, but it's understood. In a multiple choice test, you are going to have repetition permitted. So if we have 4 answers, I've got 4 to pick from here. How many here? Still 4. Still 4, 4, 4, 4, 4, 4. That's a huge number. That's 4 times 4 times 4. That's 4 raised to the 8th power, isn't it? So if you do that on the calculator, you'll find out you've got 65,536 different possible ways that the answers could be arranged. So the moral to that story is, If you don't study for that quiz and you guess at all 8 of them, you have an 8 out of 65,536 chance of getting 100. Okay, now if you cut that down and you studied a little bit, and you could narrow it down to 2 to each one, still not going to be great, but it'll be 2 to the 8th, which is, what, 2 to the 8th is 256. So now you would have an 8 out of 256 chance of getting a 100. So I guess the moral to this story, guys, is study for your quizzes or your tests so that you can increase those odds. All right, another one. On page 471, it says how many 3-letter signs? All right, so 3-letter signs can be made from the letters in the word numeral if no repetition is permitted. So we have to count how many letters do we have. 3, 4, 5, 6, 7. Is that what you get? So in the first position, I have 7 letters to pick from. But because no repetition is permitted, I pull one out and I lay it on the table. I don't put it back in the bag. So now how many letters are left? Now there's 6 left. I pull another one out, I lay it on the table. Now how many are left? 5 are left. So the total number of ways we just simply multiply. 5 times 6 would be 30, times 7 would be 210 different signs, that 3-letter signs that we could make from those letters. All right, one more before we move on to something else. It says Jamie had 5 places to put items in her display. She had 38 different items. How many arrangements were possible? Now this one doesn't say whether repetition is permitted or not either. You have to use a little thinking here and decide. If this is in a store and she's got 5 slots to put things on the shelf to show, if she puts an item in this spot, can she also put it over here? No. So is repetition permitted? No. Once you put it there, it's done. You can't put it in another spot. So we have 38 to pick from for the first slot. Okay, that's 1 used. How many's left? 37. And then 36. And then 35. And finally 34. I'm not going to even try to multiply that out. It's a huge number. If you look at the bottom of page 471, they multiplied that times that times that times that and got 60,233,040. That's that many different ways she could arrange 5 items at a time in her store. That's a lot of different ways. I wouldn't recommend that somebody spend their weekend trying to figure out how to do all those different ways. Okay, now then turn to page 472. We're going to talk about probability now. Probability is the number of desirable outcomes I'll just leave it like that, divided by total number of outcomes possible. So, an example. If I asked you to tell me what the probability of tossing a fair coin and it coming up heads would be, how many heads are there? 1 out of how many sides of the coin are there? 2. So the probability of me tossing a coin once and it coming up heads would be 1/2. All right? Next, we're going to talk about die. There are 6 sides of a die. So if I ask you to tell me, if I roll a die, a single die, what is the probability that it will come up a 5? How many 5s are there on the die? 1 out of how many sides on the die? 6. What if I said, what is the probability of tossing a fair die and it coming up a number greater than 4? How many numbers greater than 4 are there on the die? Well, there's 5 and there's 6, so that would be 2 out of 6, which would be 1/3. All right? So it's the total number of desirable outcomes divided by the total number of possible outcomes. Now we're going to talk about throwing 2 die, which is what most gambling tables use. You roll 2 die and your score is whatever you get as the sum of the 2 die. So you're going to have to reconstruct this table on your homework and on your test. I'm going to be looking for it on every single homework problem and of course on the test when you have to deal with this. So it's pretty easy to reconstruct it. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 5, 6, 7. You can probably see how this goes. 2 plus 1, 3 plus 1, 4 plus 1, and just keep going. 2 plus 2, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 7, 8, 9, 10, 11, and you'll know you did it right if you end up with a 12 right here, because if you throw double sixes, you get 6 plus 6 is 12. Now, what I suggest you do after you draw that addition table is you mark these out because they're not involved in the probability table. So the problem that you might have says 2 dice are rolled. So here's our outcomes right here. What is the probability of A getting a sum of 7? So count the sevens. 1, 2, 3, 4, 5, 6. Out of how many numbers are in this table right here? Well, there's 6 times 6, which is 36. So the probability would be 1/6. Letter B. What is the probability of getting a sum greater than 8? So I'm only going to count these numbers right here, greater than 8. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 36. And that reduces to 3 goes in there 5 and 3 goes in there 12. So 5/12. Oops, excuse me. Did I do that wrong? 1, 2, 3, 4, 5. Oh, I'm so sorry, guys. It said greater than 8, not greater than or equal to. So I did that wrong. We don't count the 8s. Okay, we don't count the 8s. So we're not going to have 15. We're only going to count from here. Greater than 8 starts with 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 36, which reduces to 5 out of 18. See how careful you have to be to pay attention to what it's asking for. It didn't say greater than or equal to 8. It said greater than 8. So we don't count the 8s. All right? Okay, bottom of page 473, back to that coin I was talking about, a fair coin because it's not weighted. Yes, there is such thing as a weighted coin where you could weight it by just putting a drop of nail polish on it, and it would be more likely to end up on that side with the nail polish than it would on the other. But we're talking about a fair coin, not a weighted coin. So in the bottom of page 473 it says, a fair coin is tossed 3 times. What is the probability it comes up heads every time? If you're talking about multiple probabilities, you multiply the probability of each thing happening. All right? So it wants to know what the probability of it coming up heads on 3 different tosses are. So the probability that it comes up heads on the first toss is 1 out of 2 times. What's the probability on the second toss? Still 1 out of 2, because there's only 1 head out of 2 sides. Last, the third toss, 1 out of 2. So 1 times 1 times 1 is 1 over, this is not 3 times 2, it's 2 times 2 is 4 times 2 is 8. So we have a 1/8 probability of it coming up heads on every time if we toss it 3 times. Now this last one is kind of tricky. If I sit here at the desk and I flip a coin 20 times and it comes up heads 20 times, and then I ask you, what's the probability that it's going to come up heads the next time I toss it? What are you going to say? It's still 1/2, isn't it? It doesn't matter how many times I did it in the past. That does not affect what's going to end up happening in the future. So this problem says a fair coin is tossed 4 times and it comes up heads each time. Who cares? It came up heads each time. What is the probability it will come up heads on the next toss? It's not asking for what's the probability of it coming up heads on all 5. It says what is the probability it will come up heads on the next toss. That's still 1/2.